Network address translation, we learned that it is changing the layer 3 address on the layer 3 header. It's not a simple job. We need to decapsulate, go to layer 3, remove the source address, put another address as a source. That you need to do for every single router. It's a painful job. Means for the routers, it's a painful job. It takes a lot of time and processor. So definitely this is not a good scalable approach, but there is no other option if we are not ready to do some tunnelings. So I do not want to get into that high level of networking because we are in NATing chapter. There are two types of, actually three types of NAT. One is one-to-one, we saw. The advantage of this NAT is bidirectional. Bidirectional, meaning with this address, people from outside can come in, and from inside, the people can go outside. For example, I've got a computer here whose IP address is 10.0.0.1, and I got a router, and let's say here 20.0.0.1, and I got internet. I'm going to keep this as a router, and here is a network, let's say 2.2.2.2. Assume this is an external device that you are pinging like Yahoo mail server. Fine, this is the edge router. Now whenever I go from A to B, I need to have a public identity. Otherwise, this public internet cannot route the packet, because to this internet there are many people connected. They may also have 10.0.0.1. Not they may have, they are having, many are having in their organization same 10.0.0.1. And because it is a private network, we don't advertise it to the internet, and internet will also do not know about this 10 location. And let's say here you got 30. So internet knows only about 20, 30, 2. Internet knows only about these networks. So whenever A talks to the internet, it needs to take this address which internet knows to respond. Whenever this B speaks, he needs to use the address 30.0.0.1 which the internet can respond. This is what we call it as public IP address. This is what we purchase every time whenever we want a WAN service, an external service. So we may have only one IP address, or we may have a more than one, let's say 20.0.0.2 is also given to you. You purchase two public IP address. Now this, you may not have it on an interface, but you can use it for netting. You can say whenever A goes to outside, it needs to take this identity. See, this is need not to be there on the interface. I repeat, this is the main point why I'm revising this topic. I do not want to use that same address on the WAN interface, because I got another address for, let's say this is very important person of this office, let's say is the director of this office. For the director's computer, I want to give a dedicated IP address. So I purchased an address which is not shared with other employees. Now this address need not to be there on an interface in order to use it for translation. All other employees in this company may be mapped to this one single address, but there is not static net, there is dynamic net. We'll talk about that later. Now, what is static net? One-to-one. For this director's computer, I'm giving one dedicated IP address. Whenever this address comes, only then this gets mapped. For all the rest of the people, only this will get mapped. So let us not talk about all the rest of the people. Now let us focus on the director computer. If you go to anywhere in the internet and see, whenever director sends any traffic, if you sniff and see, the address of the packet will be 20.0.0.2, not 10.0.0.1. It is not 10.0.0.1. It is 20.0.0.2. So this address is getting mapped to this. The mapped address, that is called NATing. So anyone in the internet, they don't see your original identity, they see your mapped identity. Now when Yahoo responds, to whom it will respond? To the address from where it received. It receives from 20.0.0.2, so it's going to respond to 20.0.0.2, and it comes here. And this router knows that I have to map it to 10.0.0.1 because this is the one which was doing that mapping. It's bidirectional. Look at this. If someone from Yahoo tries to talk to A from Y, if someone tries to talk to A, what address they should use? They should use 20.0.0.2. Any traffic that is going to 20.0.0.2, it gets mapped to 10.0.0.1, isn't it? That is what we call it as, that is why we call it as bidirectional. That is why we call this as bidirectional, two-way translation. From inside, if you want to talk to outside, this will support. From outside, if you want to talk to inside, this is going to support. This bidirectional advantage is not seen in the other two type of NATs. Static NAT is bidirectional, whereas the other NATs, dynamic NAT.
So just a question.
Yes, please.
So if it's not configured at the interface, the IP address, the private one, sorry, the public one, does it mean that it's a virtual?
No, there is no virtual nothing. We are telling the router that you can map the address 20.0.0.2 if it is coming from 10.0.0.1. So NATing will do its part. NATing will change the source address from 10.0.0.1 to 10.0.0.2, which you are giving statically to get mapped. 20.0.0.2. Now, routing is another part. That's not the why NAT should do everything. NAT's job is to translate. I'm done. That's my job. I have done. I need to simply take 10.0.0.1 out from the packet source address, and I need to put this 20.0.0.2. That's what I'm giving. I'm ordered. I'm given ordered to do this. That's my command. That's the command given to me. I'm doing my job. NAT will finish its job. Now, if that 20 that I have mentioned is in the routing table, of course it will be there in the routing table. You see, if you have 10.0.0.254 here, the routing table is going to show like this. 10.0.0.0. See, it's not going to have an IP address. Listen, very important. It's not going to show you IP address in the routing table. It will show the network is connected via Ethernet 0. 20.0.0.0 network is connected via F00. That's all routing table needs. They don't care what the end, the host portion. In order to route the packet, they need only the network. So when you do the mapping, the source address changes. Is the source network available on the router? Yes, it is available. So now where you want to go? I want to go to Yahoo. Do I have the route in the routing table? Yes, it says go via F00. That's what takes me to the internet. And a packet goes here. That's all. Did you get the point?
Yes, sir.
So in short, the answer for your question is not necessary to have the 20002 on interface. Now, let us talk about the dynamic NAT. We all have the routing table. Now, static NAT is one-to-one. Static NAT as a result provides bidirectional, but static NAT is not cost effective. Leave cost, but static NAT is not possible if you have 1,000 computers to get netted. If you have 1,000 computers, you cannot buy 1,000 public IP addresses. Even if we give money, we don't have address left anymore. The public IP addresses are limited. The entire world needs communication, and if they give you 1,000 IP address, public IP address, where will they go for others? Not possible. Maybe one or two or three or maximum five if you are very rich and big company. If you really need 5 IP address, they make you 5. Don't expect more than that. Not possible. No one will be able to give in first place. Even if we give money, they don't have it to give. They don't have addresses to give. Finished already. IPv4 is finished. That's why we are in IPv6. Anyway, you will not be provided with too many IP addresses. But you want all 1,000 employees to go online. How is that possible? It is possible through dynamic NAT. Dynamic NAT allows you to share one address with many inside source. Yes, you see I got 10001 already dedicatedly given, let's say because he's a manager, I said I want to give a dedicated one. I've given. But I got another 1,000 employees. I told you 10.002, 10.003, 10.004, 10.005. We got too many. And if they all want to go to Yahoo, we are going to use one address. It can be this one, but this is already given. So you cannot. It can be this one address, or you may have another address also, which may not be there in the interface, that you want to share with the 1,000 people. I repeat, the address that you want to share with this 1,000 people need not to be there on the interface. But if you wish to use the address on the interface, you can do that. So anyone who goes out, you can say use this. See, if that anyone is 10.001, because already static NAT is done, that is given important. So for 10.001, this will not be given because static NAT is always preferred first. If there is no option of static NAT for that source, then it checks the dynamic NAT. Dynamic NAT says use this address. Let's say you do not want to use the interface address. You do not want to use the interface address. Then this address you can map, and you can say use this address. Let's say this man 10005 is mapped to 20003. 20003. 10005 is mapped to 20003. Right. Now, he goes outside. Return traffic will come to 20003. Return traffic comes. Router knows to whom 20003 is currently given. So it does the reverse NAT and the packet is delivered. The reply packet comes. But if Yahoo initiates the packet, the source is 2222. That is not matching with anywhere map. If Yahoo is initiating a traffic to 20003, it will not go to 10005 because when 10005 was going, the return traffic allowed, and then this mapping got removed once the conversation over. After the conversation gets over, if Yahoo tries to reach 20003, it cannot talk to Mr. K. It cannot talk to K. Because no more the mapping exists. The dynamic NAT, as the word says, dynamically gets created whenever the conversation gets initiated from the inside, and it gets removed dynamically when the conversation gets over. Why? Because there may be another person who wants to go outside. So this cannot hold this address with this 10005 all the time. As soon as the conversation gets over, it has to be removed so that this 20003 will be available for others to use. Yeah, now 10004 is initiating the conversation. And now 10004 takes that address and goes outside. So if Yahoo tries to reach to K, not possible. This is not bidirectional, this is unidirectional. So you are sharing that single address with all insiders. It gets dynamically mapped, and the map gets removed dynamically when the conversation gets over. That's why it is called as dynamic NAT. But there is a disadvantage in this. What? Only one person at a time can use this address. As a result, when J is talking, K cannot use that address. K has to wait for J conversation, J to Yahoo conversation to get over. Needs to wait for the conversations to get over. J to Yahoo conversation should get over for others to use, K or L or M to use. What you will experience in this is slowness, because the others need to wait when someone is using. If that someone is using with a long session, then packets will even get dropped for others because they cannot wait for long. Slowness, in the network can also be caused because of NATing. People don't focus on NATing when they experience slowness. They do troubleshooting with various things, but they don't really focus on NATing part. There are chances for the trouble caused by NATing because of long wait. Packet also will get dropped. So dynamic NAT is not a recommended one. What is recommended? Dynamic NAT overload is what we need to do. If your option is not a static NAT, then instead of doing dynamic NAT, try to do dynamic NAT overloading. Dynamic NAT overloading, as the word says overload, you are going to use one single address for many at the same time. Okay. Now, I may have this one only single address. I may have also a pool of address. If it is a simple dynamic NAT, and if I'll use this pool, only 3 persons at a time can go online. The 4th member needs to wait, which we learned. But this one which we are going to learn now is, which is also called as patting, port address translation. Dynamic NAT overloading, which is also called as port address translation. Yeah. Dynamic NAT overloading or port address translation, PAT. It uses the port numbers to resolve this waiting time. How? For patting or for PAT or dynamic NAT overloading, really you no need more addresses in the pool. Let's say this is what actually reasonable number of address we need. Let's say you got 1 million employees in the office. Okay, let's keep it simple. You got 1 lakh. So 1/10 of 1 million is 1 lakh. 1/10 of 1 million is 10 lakh. Indian term, lakh. Okay, anyway, 1 lakh people, 1 lakh employees you got. 1 lakh employees you got in your organization. And this is 1 lakh employees. If all goes online at the same time, this one address may not be sufficient. Because the maximum number of port number that we have is only 32768. Sorry, 65536, 65536, 65,536 port numbers. We are going to use the port number along with the IP address to provide a unique MAP address. Then with one address, you cannot have more than 65,000. Because your employees are 1 lakh, means double the amount of this, approximately. You need another one. Or that another one can be the address on the interface. It need not to be on the pool also. You need just 2 addresses. You may have one address on the interface, the other one on the pool, or you can have a dedicated 2 address in the pool. That's your wish. But for 1 lakh employees, 1/10 of 1 million, you need just 2 addresses. Now, how it is used, how the port numbers are used, let's see that. So let's say this guy is A, B, C, D. When A goes online, if packing is enabled, which is also called as dynamic NAT overload, you can call this as port address translation or dynamic NAT overloading. So let's say if this guy C wants to, where is C? A, B, this guy is C. If C wants to go online, the packet comes 10004. It is given that first address in the pool, 20003. You see, when a packet is sent from A, it will also come with the layer 4 port number. Let's say the port number is 5555. Whenever a packet is sent, the port number is also added. We learned in OSI model. Source and destination port number will be given. Now the source port number is copied here. Now whenever A goes online, 10001, let's say that comes with some port number 3333. Same IP address 20003, but the port number is 3333. Listen, when Yahoo receives the packet from C, it receives the packet from 20003, port number 555. When Yahoo receives packet from A, it receives from 20003, same address, but the port number is 333. Now, all the requests coming from C will be responded to this port number and it gets translated to this, not to 10001. All the requests made by A will be responded to this port number. As a result, this gets mapped to this address and packet get delivered only to Yahoo. Sorry, A. So what I'm coming to say is, request of C will not be responded to A. Request of A will not be, the response packet for A will not go to C, because the port numbers are there as a reference to provide the unique identity of the original source. You see, just one address, you are able to provide service parallelly without any waiting. That's why we call it as overload. Overload. Dynamic NAT overload. And because the port numbers are involved in this overloading, it is also called as port address translation PAT. Yeah. So we got NAT, static NAT, dynamic NAT, and PAT. Any question? We're going to do this exercise now. Do you have any question before we do the lab?